Hello guys, sorry, we have some issue with computers. Thanks for coming, and it's great that I'm here, and also I can some present in front of the audience. I just wonder there is a lot of people because we are the farthest of the hall, so perfect. Today I would like to share with you how we build the group data lake, where we are, and what the tasks are ahead of us. Yes, the PowerPoint template what gave me required some bio information. So I have worked for Erste Digital for 3 years. Before I started Erste, I worked as data warehouse support and campaign management analyst at some bank companies. Then I work as report analyst and software developer in some computers company. Then after that, I work as data warehouse developer. And in that time, I had the opportunity to get in touch with Hadoop technology. And it's quite obvious that I still in this field. Currently, I'm the third level support of our group data lake. But this presentation is not about me, but it's about the subject, what is the group data lake. Every good presentation starts with with, because we are not able to use Slido for this. Just read the question, what does the term of data lake means, and the correct answer on this. I just wait a couple of seconds. Here we go. The right answer is the first one, of course, of any conference, perfect conference like this. It shouldn't miss something like data lake session and so on. So that's why I'm here. Developer's nightmare. So you can guess the second question is also right, because sometimes when we build something on the group data lake or on Hadoop technology, it's quite tough to doing, and also it requires some lots of sleepless night to build something on the Hadoop. But Hadoop is still good technology. And because you are a wise audience, you're also guessing that the third answer is also the right. Just the evolution of data warehouse. Yes, before data lake, we have terms like data warehousing, then BI, like business intelligence coming through. Now we are data lake, and later on some new terms emerge like data hub, data mesh, what we have presented in before lunch. By the way, this was the great presentation by Professor Dark. Data lake. What does the data lake, this term means? Data lake is the central repository that allows us to store structured and unstructured data with at any scale. You can store your data before you can load or store your data before defined in the structure before. And the third bullet of this definition is the run different type of analytics from dashboarding, reporting, data analytics, machine learnings, and many other use cases. This definition comes from Amazon. I pretty like much this definition, but I can see two, let's say, issues or drawbacks. You guessing which one? I already pointed with the yellow. At any scale, yes, Amazon can say that you store data at any scale because they are on 100,000 servers. So for them, it's quite easy to say any scale, but the reality at the company level is quite different because you are limited by hardware, what you have on the premise, or the budget, what you basically have on your solution. And also the second one thing, what I can see a little bit awkward is without having the defined structure before. Yes, that's true that in data lake you can store any type of data we need, and then without any problem. But if your user cannot read this data properly, and yes, basically your user coming from relational database like Oracle, SQL Server, they quite they used to work like SQL Server, SQL language. Then they made your Hadoop or group data lake like useless because they cannot read your data. Data lake is just the, let's say, the term of let's say virtual term because your data lake can be built with different type of technology. We at Erste, we decide to use Hadoop. Yes, Hadoop. What is the Hadoop? Also some definition for those who's not familiar with this type of technology. Hadoop is the software, and Hadoop software library is just the framework that allows you to distribute in processing of large set of data on cluster of computers. It's designed to scale up from one single computer or server to thousands of computers that work together, and the library itself is designed to detect the handled and can design it to work with and then detect and handle failure and deliver the high availability. I think definition is not so complicated. Maybe I just put the third terms that Hadoop can detect the failures. It meaning that if you have your Hadoop run as the cluster with many nodes or computers, then if one or some of the computers are going to down because of some issue, your cluster itself is working, let's say, without problem, and basically users cannot detect this failure. When we talk about Hadoop and not mention HDFS, it would be mistake because Hadoop without HDFS is like developer without access to Stack Overflow. HDFS, what is HDFS? Is the Hadoop distributed file system. It's a distributed file system designed to run on, let's say, on every hardware. Let's say it could be laptop, could be old computers, or would be really top-edge server. HDFS is highly fault tolerant and designed to be can be built on the really on low cost hardware, and will be run without problem. When you store your data into the HDFS, your data is replicated by 3. It's by default. It could be increased to be more, let's say, fault tolerant or decrease, but I wouldn't recommend this. Otherwise, when your one node will fail, you might lose data. And HDFS provides high throughput access to application data. Basically, it's like framework where you put your data, and this HDFS can support lots of use cases what you want. Just briefly, what is the key difference between Hadoop and relational databases? It's for example, type of storage. On the Hadoop, everything is stored on the HDFS on the file system. Where on the other hand, on the Oracle, you put your data to a relational database. Verification design or design as such with the Hadoop. Hadoop was designed to work as a schema on read, in the meaning that you put everything, every data to HDFS, store them, and it's up to a client, in the mini client like application, to proper read your data from HDFS or from Hadoop against the Oracle, where you need to create structure, create table, create data, the right database, data types, and then the user can access this data without problem, without querying. Storage for data, basically HDFS can on the HDFS can store any type of data. It could be CSV file, JSON, Parquet, could be also video, pictures. There is no limitation about it. Instead of Oracle, that you store data to the table. Basically, also yes, on the relation database you can store also CSV, XML file. Also on the blob you can insert some PDF also and video. Usage of the Hadoop. In most cases, Hadoop should be used. It's basically used for analytic purposes, and relational databases. It's very good in the transaction processing. And in terms of using of data or accessing data to Hadoop, every data is stored on the HDFS, but on the top of HDFS, you can build or implement some, let's say, databases. It's not the real databases, but just the SQL engine or SQL viewer, let's say, that can access your data, and you can query this data with SQL-like languages. Instead of relational database, there is standard ANSI SQL notation. Then, when we Hadoop or Apache Hadoop is 100% open source. You can download from internet to your computer, play with this, and learn. But in the enterprise level or in the company, where your group data lake is more important, and your user is relying on your data, on that your data is precisely, there is up to date, and your solution is available almost 24/7. Then your group data lake should be supported with some good vendor. We decided to build our GDL with, of course, with technology Hadoop, and our Hadoop is licensed by Cloudera or CDH. Cloudera is an American company that offers enterprise data management system, and what we installed on our group data lake cluster is CDH. CDH stands for Cloudera distributed Hadoop. Is open source software distribution that include the Hadoop, what is the core, and some others. And CDH comes with the others application or open source project that can be used for processing, withdraw data from sources, store this data to HDFS, and provide this data to user. What was the motivation to build GDL? First, at the beginning, the first motivation was to archive historical data from the commission system. For example, it was the data warehouse or old data warehouse system. It was replaced in new one, but the structure of data wasn't aligned. Then, in sometimes it ran two different data warehouse systems, but the old one was decommissioned, and these data were still needed, because of some analytics use cases or because of regulatory purposes. Then the second point of using or building a group data lake was to archive historical data from production system. For example, in the one relation database that is quite heavily utilized, and the user in many cases use only, let's say, half year data, and they don't use the old one data, and because it was the performance issue on this side, we decided to download this data to group data lake and delete from sources. They don't need it. Then another use case was to replace legacy systems. What was outdated, and we bring a new functionality or new feature on this solution when we migrate this solution from this legacy system to group data lake. Then, of course, collect all information to one place, where the really advantage of this that business user cannot go to one system, get the data, store them to computer, to Excel or CSV, import somewhere else. All data within the Erste is stored in the one place, and it's quite convenient for user. Just log to a GDL and dig any data from Erste. Of course, then building some analytic platform for consumer, not for only for regulatory requirements, in the meaning that Erste Digital is not a bank, but we are working for Erste Bank, and they need to store data because of some regulation from European bank and banks where it's located in the countries. And so this is the regulatory requirement, and also for ad hoc analysis. Also, it was the motivation to build as a base for some machine learning models and other analytic use cases, and basis for some agile data mart. And the feature was not pretty supported from the relational databases. How our GDL group data looks like. I don't want to impress with some numbers. Just to overview, we have 15 nodes, let's say computer or working nodes. One edge node, it's act like a gateway when we process some file integration. So some sources put the file on the edge node, and from edge node we load it to group data lake. And there is two terminal server which act as a jump host. One is Windows, one is Linux, but it's not important. This jump host is used for business user to log in and play the data with you, Zeppelin, Jupyter, and time. There is some numbers about the resources. You can see as on the GDL, there is not only the solution what we run. The cluster also run another solution. One is the CAPS ADM, what stands for Agile Data Mart. When we put collect some data, aggregated data, and then is used for some analytical use cases. And the third solution is BDSL, stands for Big Data Science Lab. This is the solution where is the collect of user sandboxes. When create them some teams, they want to play with data, do some model, and test this model. We create them dedicated Hive database space on HDFS. If they need it, also we create Docker container with own Python environment, Spark environment, and so on. This is on the figure. You can see the monthly processing not so good as on the previous presentation on the Google Cloud, but I can point maybe 1.1 trillion of rows what we currently have on GDL, and every day is of course increasing. And what I pointed is 170,000 jobs per month. Please remember this, and I explain and elaborate more in the next slide. How does the GDL integration looks like? Okay. On the left side, you can see the sources. Not going to too details. On the right side, we have our users or downstream solution would get data from our data lake. As sources, currently we have relational databases and file integration, and the third is Kafka, where getting some data and stored to HDFS, and then they are using for Agile Data Mart. When we have data or integration with Oracle or relational databases, we use Scoop. What is comes directly in CDH package, and for file we use base script, basically files landing to SFTP server, and we get this data and the process with base script. With integration with Kafka to data lake using Python script. In the middle, it's obvious, it's called Fusion middleware. As an ETL tool, we use ODI, Oracle Data Integrator. It's fine. It's quite fun, and we can say that we are living in the golden age of IT, when every technology can be put together and work together. Because our cluster is Oracle Big Data Appliance. We also we use Oracle Data Integrator, and anyway, we run the Hadoop. So yeah, currently any technology could be work together. So as an ETL process, also an ETL tool, we're using Oracle, and all jobs are orchestrated or scheduling by Atomic. Group data lake, it's quite easy. On the bottom, there is HDFS, where all data is stored. On top of the HDFS, there is Apache Impala and also Hive. As I mentioned, Apache Impala and Hive is just the SQL viewer of engine that user can access data with SQL-like notation. But in reality, it's not the real databases. And top of this tool, there is also Spark that our user can use, or Python. In terms of integration with our downstream solution, we have TIBCO. TIBCO Data Virtualization. It's a tool that offers user to connect to TIBCO, and TIBCO hide the underlying source from user. So basically, the user doesn't care if your data lying on the SAS, on Oracle, on the Hadoop, or it's an Excel file, PDF file. Basically, the user doesn't care about this, but he can play with the data or join these data sources or table together with the TIBCO. For data science, what we support our users, they use Apache Zeppelin. It's also part of CDH distribution. They can play with data with Jupyter, and for some data science project, they use NIME. In terms of reporting, our group data lake is integrated with Tableau server and Tableau desktop, and also Web Focus is also integrated in our group data lake. Web Focus is also reporting tool. Also for some analytics purposes, also SAS is integrated with us and get the data from us and do some statistic model. Our new customer is called Erste Container Platform. Basically, is OpenShift containerism platform. They run, or on that OpenShift they run all own a container with some application. Some of them is Jupyter Hub. There are connect to our GDL and via, I think it is via Impala, and get data from GDL and play on the Jupyter Hub within OpenShift. Metadata driven model. On the previous slide, when I point you remember 170,000 job monthly. Of course, this is not feasible. That this amount of job what we have is developed by human being. In fact, in our team we are 6 or 7 people. What we are working on GDL. In this huge workload of job, probably we need 100 or 200 people. So how we build our job is by using some kind of metadata. How it works? When we going to integrate some sources, we ask them for metadata. In the meaning, if the source is a relation database, what's the name of table, what's the name of columns, data type, date mask, when they provide our data, and lots of information, as much as we can collect from sources. And we put everything we put on our CMT model. It's a combination with Start and Snowflake schema site in the Oracle. We push the button, or how we call it, job grinder. We put everything inside the grinder, and the output of this PLSQL package, is the main is XML file. XML file is a base for ODI. Basically, in this XML file is like mapping to point on which sources our job needs to connect, on which table can grab which table, which column, what kind of data type, and so on. So the basis of this job grinder is XML file for ODI. Then when we have this metadata, it's quite easy to export some DDLs. For example, if we have a new source, when there is new table, and we need also create table in the Hive in our group database, where, for example, this new tables is 100. It's of course some we need to automatize this in some way. So the output of this job grinder is also DDL statement, like create table. If we already have this table, and basically we need to change some columns or data type, we generated also DDLs for alter table. How we present our data to user is in 2 different ways. First way is a full set of data. It's basically views on top of the data, and the second set of views are fully anonymized. Basically, if some users need to play with data, but doesn't need to know the name, or I don't know, transaction, the the full detail of some data, then provide them the anonymized views. So also the output of this job grinder is DDLs for creation of this view. When we have this CMT data, we can populate table in the ab initio, what is let's say metadata management tool, and users who want to export our data on the GDL, that is the first step. They log into ab initio, watch, can see what kind of data we have, what the tables or interface has the column structure, where this data coming from which source, and so on. So for them, it's just the good and first point to start how to export data on our Hadoop environment. All right, and this metadata-driven model is really heart of one-click automation project or initiative. Basically, what is behind this? There's what I mentioned before this slide. When we need to integrate new source, we need to collect all information, what kind of data we will ingest to our GDL, and of course, without this data, it's not feasible to do anything. Because sources can change their structure in some awful way. Some of them change sources every 3 months. Some of them can change their structure every month. So if you have a lot of sources, it's also not feasible to do them manually, and we maybe not able to do every time recreated our structure in the Hive tables. So then we worked on the one-click automation project. And what is this? When a source system want to change something on their structure, and they are integrated with GDL, with our solution, they send us the changelog, where it's stated with interface, on which column will be changed, if there is a new interface, new tables, or any kind of changes they put on the changelog, and also send us the sample data. What we do is import this data to our engine. This engine compare this new information with metadata what is inside it, and do some change. If there is new interface, create the DDL statement for creation of tables. So if there is some changes on column, do some alter changes, generate this command to the file, and then this engine run this script with all the DDL statement automatically. And then when it's all done, we also send back information to our users that our simulation is okay. We haven't seen any issue. Then we can reload this change on the higher environment, for example, on the UAT, and then we run the same process over again, do some testing about data if everything's fit, and then if everything's okay, then we deploy every change on the production. What the upcoming activity or what tasks are ahead of us? Currently we play with NiFi to get data or transaction from Kafka. Then we store them to our GDL cluster for some analytic use cases. The second initiative, what we have in front of us, is building ODS, operational data store. It's very same the topic as the previous one. We store transaction in ODS, And because HDFS it's not so designed, not so quick to get data from, let's say, from outside of the cluster. For example, for microservices, therefore we will create ODS for this. To finish, one clear automation, as mentioned on previous slide, everything is in place, but what we need to do is just automate the full project. That every this step, what was mentioned before, is doing in automatic way. And the big project, what is ahead of us in the next year, is to migrate CDH to CDP. What is the new version of Hadoop provided by Cloudera. And it's not about migrate data from one cluster to another, but then we decided to refactor some partitioning due to some query performance. On the CDP, there is new software for access management. Instead of Sentry, there will be a Ranger and some more point. I've also forget for another buzzword, cloud. Yes, when we migrate data to CDP, data itself will be stored on premise hardware, but the backup will be stored on the cloud. Why is worth to work with Hadoop? Before I started work with Hadoop, I haven't had any clue what is distributed company, how, let's say, Java work, basically what is ODI and so on. So when I started work with Hadoop, I get to learn lots of new stuff. As I mentioned, like Java, because Hadoop is very close and use JVM, so that you know what is Java heap. Let's say how Java log some stuff and so on. Also, when developers work with Hadoop on daily basis, you use Bash scripting. Also, when people start working with Hadoop, they get knowledge about Python, Spark, and many others technology, what is mentioned on the slide. For example, Git, we have the professional Git. Yesterday was pretty much lab. And many others technology and application. This is the last slide. I rewrite a little bit the famous poem from famous film. Hadoop is like a box of chocolate. You never know what you're getting there. That's quite fun, but in reality, it's really do. One day, it's everything fine, everything is green, Hadoop's work perfectly, and the second day, everything is going to down. Nothing is work issue by issue. And yes, that's work with Hadoop, but we still believe and Erste is a good technology to work with it. And thank you. It's any question? Do we have time for question? That is for. By building data lake on premise when there are many options like major cloud providers, money. Basically, what is the most expensive part of building a data lake on the cloud is network traffic between your company to cloud. The storage is not such expensive, but yes, you pay not only for storage, not only for computation, like was mentioned before, and you also pay for data transfer. And also, the issue is about data. Then basically, you provide this data to public cloud, and beside any day, you can see that the hackers get data from there, and then. And because we are using banking information, I think premise may be good option. In case of your organization data lake, who is owner of data point? Owner of data is the data who provide us. Basically, if some source provide the data, they fully responsible what is there. In the meaning, we are responsible to offload them from sources, store them in accurate way, but the owners of data is the source. Also, when we put the new sources to our solution, owner of this data is involved in testing. Does your DVH relational technology communicate with data lake? Yes, sure, via Scoop. When we offload data from Oracle to Hadoop, we are using Scoop. And there is another possibilities. It's called Oracle Heterogeneous Services. I hope it's the correct form. You can install some package on the Oracle, and you can see data directly in Hadoop via JDBC or some kind of technology. Do you store servers, info, instruction, and traffic in TL? If yes, are you using some agent or some custom connector? Anything technology? Yes, everything what is run on the cluster is logged. Currently on the CDH version, what we have is called Cloudera Navigator, and some others log is collected by Zabbix. All right, I think we're running out of time. If you have any question, yes, go on. Yes, access is managed by Sentry. Amount of users, it's hard to say because when some users goes directly at our Hadoop and using Hue. Some of them use Jupyter Lab, some of them Zeppelin, many others use TIBCO, data virtualization. But in roughly about 300 users work. And the access management, we have custom application what is storing or creating some functional roles. On the function roles or behind these function roles is Active Directory groups, and under the Active Directory groups we can manage access by Sentry. Yes, it's a technology way, and who is responsible? Business owner of our cluster is responsible who will see which data. So he need to decide with what kind of data can access by whom. Yes. Yes. Understand. We group the permission based on source. For example, if when one source from Oracle, basically these all tables has one groups of permission, has own Sentry roles. Then other source has own source. And if, for example, one user need access for both of them, the user need to request access specifically for first source and for second source. It's split by source. If no any question, I will be at Erste booth. I will be fully available for us. Any question? Thank you.